Hey everybody, this is your last video on linear regression. Okay, and this one is mostly on nonlinear regression, actually, which is more of a bonus type topic. It's not something that shows up very often on the AP test. So if you are feeling like you don't have the time to watch this video, that's totally okay. Um, I'm not going to add any like quiz questions or anything like that, homework questions. Very few will have anything to do with nonlinear regression. Um, so, but this video will be pretty short regardless, okay? So every once in a while, you'll see data that is curved rather than linear, right? You can see some examples on the left side of your screen there, okay? So that data may fit. It could be quadratic data, cubic, exponential, logarithmic. There's lots of different curved relationships that we could use to model curved data. Okay, the most common though are the power model, right, which is like a quadratic or a cubic, and the exponential model. Okay, so what we have to do in order to use our linear regression tools is we have to convert our nonlinear data into linear data. Okay, there's a couple of ways to do that. Okay, if you have an if you have a power model, for example, right, you have quadratic or cubic data. What you can do on a calculator is you can take the original coordinate points and either raise the x variable to a power, um, which essentially, say if you look at the data on the left right here, and this graph on the right of the slide, right, you can either, with this data, this looks kind of cubic, right, or maybe quadratic, right? So what you can do is you can either take these x values and increase them, which will kind of take your data and stretch it this way, to make it more linear, right? Um, or you can take all of the y values and root them, okay, which will make them smaller, okay, which will kind of take the curved ends and move them down, right, to turn into something a little bit more linear, okay? Other strategies include transforming with logs and natural logs. That really is the best strategy to use, no matter what kind of curved data you have. So you can take your original data point, say your original data points are xy. You can just apply the natural log or the regular log or the natural log. I typically use natural logs. And that's what you'll see most often, and take the natural log of the y variable, right? So for example, in this graph right here, if I take the natural log of these y variables right here, these y coordinates, right, it's going to make most of them smaller, but it will straighten this data out. So it will pull these values here, it will pull these up a little bit. And then these values here, right, same idea. It'll basically take this curve and straighten it out, right? These values will be pulled up a little bit. These might be pulled up a little bit, and a lot of these values here will be pulled down further. So it'll kind of straighten the curve out, right? So you can either just take the natural log of the y variable, or you can take the natural log of both, right? So you would have natural log of x and natural log of y, right? So this right here is the best strategy to use no matter what kind of curved data you have, right? If you want to achieve linearity, this is the best transformation, the best strategy to use, okay? So that's pretty much it on nonlinear regression, right? Like I said, it's a very rare topic because normally people teach it at the very end of the year. So this isn't something that shows up on the AP test very much, but it relates to what we're doing with scatter plots. So I figured I'd make you a short video on it. Okay. And then the last thing I want to point out to you is that you do have a lot of tools on your TI Inspire calculator to enter data, add a scatter plot, and actually run regressions to calculate R and R squared for you, which is really awesome. Um, Another tool that you can use while at home, um, that's a little bit easier, I think, is this website staplet.com. And if you click on two quantitative variables, it'll give you a space to enter data. And when you do, it will plot the data for you. So it will create a scatter plot for you. It will calculate your least squares regression line, your correlation coefficient, R squared, all of that fun stuff. Okay. But if you would like to know how to do this on a calculator, you have all of the instructions here. It's worth at least trying a couple of times. Maybe just take a random data set and try this out. Because I have no idea if we'll be taking the AP test at home or at school this year. No clue. So it's good to know how to use the TI Inspire calculator because that is a tool that you will always have available to you, like for the actual AP test. All right, you guys, so that's it for this video, and that's the last video in this unit. So I'll see you in the next video. I think I'm going to make you one more that has some free response questions for linear regression to give you some examples of AP FRQs on this topic. All right, but that's it for notes and instructional videos for now. So I'll see you in the next one. Bye, everybody.